think we're live now. Let's go back here. Let's say live now. Okay, I think we're live now. Let's go back here. Let's say live. Okay, yeah, አንድ ደቂቃ ይቀረዋል. Let's spend some time talking about day 11. So I didn't solve part 2 yesterday, and so I thought for part 1 we used this graph library called PageGraph. So we just built the graph and then used all simple path. There is an all simple path function from PageGraph, and then that's how we listed the paths in for part 1. That's why we counted the paths for part 1. For part 2 we didn't find that, like, all simple paths doesn't allow us to specify the middle points, or like that the path you're finding should pass through a given list of positions. So instead what we did is, on part 2 what I did is I used another library called pathfinding. So it has this count path function. So you give it the start position and a function to get the next node it should look at. So we just build up a hash map here, a hash map of the current node to the list of other nodes it's connected to. I think this is called an adjacency list. We just insert out here because out is not defined as an outer node in here, and then we just iterate over them to get the next one. And then there are two like conditions we keep track of: if we have seen an FFT and if we have seen a DAC. So because we need to pass through those. So and then we set those here if we find that the next label is FFT or DAC. And then you also need to give it an end condition, and the end condition is basically gonna check if, oh, is this the final node that I should be counting towards. So, and that will be like out is the final node, and we have seen an FFT and we have seen a DAC, and yeah, this runs relatively fast. So that's what I used to solve part 11, day 11. And I got the solution from this guy called Chris Biscardi. I think actually this is the first person. If you guys check out his videos on YouTube, I was learning Rust back in, I think, 2022 or something, and I think he's the first person that I saw. This is the first time that I've seen like Advent of Code. This is how I found out even that thing called Advent of Code existed. So yeah, he used the pathfinding library in his video. So I just saw his video last night and decided to do the same thing. But now we're at the final day, so let's open up day 12. Hopefully it will be easy. Again, I don't think it will be easy. It's gonna be, hopefully we will solve it. Okay. Day 12, Christmas tree farm. You're almost out of time, but there can't be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, fire poles, or conduits here that would take you deeper into the North Pole, there is a ventilation duct. You jump in. After bumping around for a few minutes, you emerge into a large, well-lit cavern full of Christmas trees. Okay, there are a few elves here frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents for all the young elves that live here at the North Pole. It's an ancient tradition to put the presents under the trees, but the elves are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents should need to be placed under the regions in a way that follows a standardized two-dimensional unit grid. You also can't stack presents. Okay, as always, the elves have a summary of the situation, your puzzle input for you. First, it contains a list of the present shapes. Second, it contains the size of the region under each tree. and a list of the number of presents of each shape that need to fit in that region. For example, okay, we have this. So this is the first the okay, this is the shapes, the what is it? Yeah, list of present shapes. And second, it contains the size of the region under each. Okay. The first section lists the standard present shapes. For convenience, each shape starts with its index in the colon, then the shape is displayed visually where pound is part of the shape and dot is not. Okay. The second section lists the regions under the trees. Each line starts with the width, length. Each line starts with the width and length of the region. 12 times 5 means the region is 12 units wide and 5 units long. The rest of the line describes the presents that need to be fit into the region by listing the quantity of each shape of the present. Okay, the rest of the line describes the present that need to be. Okay, 101032 means you need to fit one present with shape index 0, no present with shape index 1, one present with shape index 2, okay, and one present with shape index 2. Okay, so wait a minute, which means you need to fit one present with shape index 0, so 1 0. No present with shape index 1, so 0 1. One present with shape index 2. How does that get in there? That makes sense. No present with shape index 3. Okay, they are positioned in the list. 3 presents with shape index 4 and 2 presents with shape index 5. Okay, that makes sense. Okay, got it. 2 presents with shape index. Presents can be rotated and flipped as necessary to make them fit in the available space, but they have to always be placed perfectly on the grid. Shapes can't overlap, that is, the pound from 2 different presents cannot go into. Whoa, this is a space packing algorithm, like in the same place on the grid, but they can't fit together. That is the dot part. Okay, what the heck occupying from okay, the helps need to know how many of the regions can fit the presents listed in the above example. There are 6 unique present shapes on the 3 regions that okay, the helps need to know how many of the regions can fit the presents listed. In the above example, there are 6 unique present shapes and 3 regions that need checking. The first region is 4x4. In that shape, you need to determine whether you could fit 2 presents that have shape index 4. Yeah, after some experimentation, it turns out that you can fit both presents in that region. Here is one way to do it, using A to represent one present and B to represent the other. It will be something like this, so they will loop into each other. The second region is, okay, in that region you can try to fit, okay, what the heck, it turns out that these presents can all fit in the region. Here is how I can do it. I don't know how we're gonna figure that, what the algorithm is. The third region, 12 by 5, is the same size as the previous region. The only difference is that this region needs to fit one additional present with the shape. Okay, unfortunately, no matter how hard you try, there is no way to fit the presents into this region. So in this example, 2 regions can fit all their listed presents. Consider the regions beneath each tree and presents and the presents the elves would like to fit into each of them. How many of the regions can fit all of the presents listed? Wow, this is gonna be this is gonna be annoying that we have to rotate them and stuff. We have to rotate them, translate them, I don't know, invert them, flip them until they fit until we've checked all of the possibilities, um, until we've exhausted all the possibilities and make sure that they don't actually fit in the described area. Okay, let's start setting up our project. Let's create make directory day 12. Let's open up day 12. Let's go into cargo new part 1, and it's create a git ignore target, and then see cargo run. Okay, move git ignore to part 1, and then go into part 1 cargo run, and let me copy this. Inputs, make dir inputs example.text. Okay, let me create a new stuff here. Let's run cargo run here, size it a little bit, and open up the source file here. Let's get the input equals include star, which is gonna be inputs example.text. And how are we gonna do this? So let's create something like this. So struct the present is gonna be something like this. So it's just gonna be I guess points, and it's just gonna be a vec of u32 comma u32, right? Just the x and y coordinates where we've seen pounds. Let's look at the input. How large are those presents in the input? Okay, we only have 5 presents, and we have a bunch of regions that need to be checked. Okay, but I think this parsing this is gonna be something like just go over them and keep track of the I and j positions where we have a pound. I think that's what it is. So that's gonna be it. And struct I guess let's start with the present. So let's implement from str for present, and let's say our error is gonna be string. Hopefully it will allow that. Don't know if it will. Does allow it. So this is gonna be our input. So let's say I guess it will also, I guess in that case, do we need this? Because it will always just be 0, 1, 2, 3, 4, 5. I don't think we need to parse that out, but we can, I guess we can get it. So let's say f dot split once on the colon, and we will have the index comma the present I'm just gonna unwrap it. Okay, and then we'll have and then for each present, let's say points. I guess points is gonna be present dot trim dot lines dot map each line, and then for each line dot, and then for each line we also need to call dot cars, and then map on each character, and we are gonna return I comma j comma x, because here we will call, after calling lines we will call enumerate set hints false, and we also need to call enumerate in here. And then this will be because we're going down and up, this will be the y position, right? So this will be y comma, and then here it will be x comma character. So this will be x comma y comma character. Okay, makes sense. And finally we need to flatten this, and we need to filter ignore the x and y, but ch, where ch is equals to pound. Maybe we need to dereference here. Okay, so we have the points, which is it's what it is, and it's collected into a vec. Okay, it's a usize comma car. Actually, maybe we're gonna need to do some kind of like some manipulation to it, I'm sure, some kind of subtractions and stuff. So I'm just gonna make this be an I32 as I32. Okay, so that's the points. I guess, I don't know, do we need the index? I don't really know. Let me just keep it here. Let's index equals index dot trim dot parse, and parse it as a user2, and then finally we'll go down here and say okay, present is gonna be index and points. Let me just unwrap here, cargo run. Okay, I guess we don't need that then. So let's say let's call this x comma y, and I guess x comma y, and ignore the character. Okay, so that's how we will parse this region, I think. And okay, how do we parse this? Let's call this, what is it? It's a region, and it has a width comma height. And then it has a list of presents, and then the presents Last day finally up. The toughest one probably. This problem is quite like the dating part two, even harder than that. Yeah. I don't know. I'm just trying to get done with the parsing. I don't know how I'm gonna solve it either. It's like a space packing problem. It's gonna be really difficult. But yeah, hopefully. But it's the last day, so I guess we have that. we'll be done with this. Okay, so the region will have a list of presents, and so the presents are a list of the present IDs, right? So it's the sub region. Yeah, that's what it is. So they said if we go up here, they were describing the regions. Um, they said the second region is 12 units wide and 5 units long. In that region, you need to try to fit one present with shape 0, with one present with shape index 0. Yeah, so it's gonna be their index in the list, uh, their index in the list, and that's just gonna be the count, and their index in the list is gonna be the present index. So I guess you can just say present counts, and then this will just be a vec of user attitudes, and then we'll just get the call enumerate on it, and we'll need to store the presents in a hash map or something, and then I think this is it. Okay, let's parse it. Implement from str for region, and then it's implement the possibilities, this string, and what am I gonna do here? It's gonna be split by, there is a colon space, so we need to split by let s dot split once. It's gonna be split by a colon. I guess it's gonna be split by a colon, and we will have the width, height, and the counts. I'm just gonna call it present count. So let's start with the width and height. So this is gonna be again a width comma height, but it's gonna be s dot split on wrap. It's gonna be a split once with a x. I think, is that an x or is it one of those Unicode symbols? I'm just gonna, I think it's an x. If I just do find x, yeah, it's an x. There is a Unicode multiplier, so they're not using that. You're using that. So a split once and unwrap, and width is gonna be width dot parse u32, and then the same thing for width height, and then for present counts we'll need to do something like this. Present counts dot I guess we'll also need to call dot trim in here, and we'll also call dot trim in here, and then dot split white space, right? And for each map at x, it's gonna be x dot parse dot unwrap and collect that into a vec of u32, and then we just need to create a region here. gonna be something like this. Of the width, of the height. Just gotta call dot unwrap on it. Okay, and then so how are we gonna call if we call like parse with a double split with a double space, which is gonna be, it's gonna, I don't know how we can split here. We want to split exactly here, so that's 1 2, but all of them have 1 2. So we're gonna do this then. Okay, so let's say struct input is gonna be, I guess it's gonna be present, which is gonna be a hash map of usize, maybe usize to present, and regions is just gonna be a vec of regions, and then let's implement from str for this, for input. Say just shut this up. I think it's a string, or like we can say a standard error, or I think it's convert. There is an infallible thing, a standard convert infallible, but I guess for now we'll just keep it string. Okay, so what we need to do is let on the chunks on s dot split, and then what we're gonna split with is we can give it a string, right? We can say like split with a double new line, and then collect into a vec. And then so regions is gonna be late regions is gonna be chunks dot pop dot unwrap. So it's gonna be the last element in that chunks thing we created, and then after removing that, the presents are gonna be late presents are gonna be it's gonna be chunks dot map, no dot, I guess we're not gonna use it anymore, so into either dot map for each chunk. We're gonna call chunk dot trim dot parse dot unwrap, and then we're gonna collect this into a vec of like, yeah, would it be cool if we did that? So let's say it's a hash map of usize, comma, present, and then we can say there's an additional thing left here, so it's gonna complain here, but we can do enumerate, and we're done. Okay, and then for the regions, so for the regions what we're gonna do is late regions equals regions dot into, I guess we need to lines, no, dot trim dot lines dot map, and for each line to call line dot parse dot unwrap, and then collect into a region, or I guess a vec of region. Yeah, it's gonna be difficult, but let's do that. Okay, I think that's correct. And then let's return input. Say okay, and then let's say input equals input dot parse, and input are the type of input, and the dots unwrap it, and then debug input. It's gonna complain because we don't have debug implemented at a bunch of places. Okay. Are there errors? Nope, there's not. Let's just run that. I think we just finished parsing it correctly. Let's make sure. So okay, so the points for this one are in 0 0, 1 0 and 2 0, and then 1 1 and 2 1, and no 1 1 and 1, I guess 1 2 0 and 1 1 and 0 2 1 1. Wait a minute. So it's at 0 0. So 0 is the column, so 1 0 and then 2 0. And then we're at the first row, so this is gonna be 0 1 and 1 1. 1 1. Where's 0 1? So I guess we can just 1 2 3 4 5 6 7. So this should be 7. 1 2 3 4 5 6 7. I guess they're all here in that case. It's just gonna be, this is 1 0 1 2 0 1. How is 2 2 part of it? I can never make. So it's at the second row and at the second position. 0. Oh, maybe it's because it's inverted. Maybe it is inverted. Oh no, that will cause problems. Do we need to reverse this and stuff? Maybe what we're seeing is actually, so it's counting 0 0 as this, the last one, and then 1 0, and then, oh wait a minute, I need to look at that. I need to look at it in here. So what are those? What does this present look like? So debug present. Okay, that seems correct. And then we call .trim on it. That will help us remove the first line here. And we start off with the top one. And then that's 0 0, 1 0, and then 2 0. Okay, that's correct. And then 0 1 at index 0 on the first row. That's correct. And then at 0 2. Okay, at index 0, but at the second position. Yeah, so that's what 02 means. It's at the it's on the third row, I guess 0, 1, 2, and because that's the y is the line number, and it's at 0, and then there is 1 comma 2, which is this, and then there is 2 comma 2. What? What? Doesn't make any sense. Zero, 1, 2, 0, 1, 2. It's counting this one for some reason, and it skipped this one. Let's check it out with the next one. So let's see. But maybe which index are we looking at? Oh, we're looking at index 4. We're looking at this. Why? It's because it's a hash map, of course, dumbass. Okay, now this one is correct. Okay, let's go for it again. Okay, 0, 1, 2, 0, 0. Okay, yeah, the algorithm is just that. And then so these three are, and then 0, 1, and then 1, 1. Yep, that's correct. And then 0, 2, and then 1, 2. Okay, that's correct. I was being stupid. So we are looking at the wrong index. Okay, and then how about the regions? So 4 by 4, where is 4 by 4? Width 4, height 4, and it's 0, 0, 0, 4 zeros, and then 2 comma 0. Okay, so I think the parsing is correct. So we can save that. We can say commit fit implement day 12 parsing input. I think we can be sure about that. Now we need to come up with an algorithm where we iterate over each region, and for each region try to pack that many points without, so we have a list of points, right? And then we need to fit them in a region, but it's like we can't just split them out and just consider the points. We have to also keep track of like their shape, if that makes sense. So they're like continuousness, I don't know what to call it, but yeah, so we need to keep track of their, so if we have these points represented as, we have these things represented as a list of points, so we can just check if like we have enough points. So that's the first check we would need to do. Do we even have enough points to fit the given the given amount of presence within the given space, even without rotating them, even if we can split them out into separate points. I don't know if this is a good way for us. I don't know if a list of just storing them as a storing the points as a week of U32 is gonna be good. I don't think it will. It's gonna be the correct way to do it. Let me search for space packing algorithm. Bin packing algorithm. The bin packing problem is an optimization problem in which terms of different sizes must be packed into a finite number of bins or containers, each of fixed given capacity, in a way that the number of maybe this is the problem. This is our problem. Whoa, is NP hard? What the heck? Are they asking us to do research? What the heck is this? Ugh. Hopefully there is a Rust implementation of like some algorithm out there. Bro, day 2 of volume. There is no part 2 problem. Oh, did you finish part 1? I think they often do that. Like for the last day, they just give you a gift saying saying that like you're done, good job. So, oh, you've completed it. You've completed day 12. Or is that correct? Yeah, I think you've done it. Or what? Okay. I solved part 1 using magic, you know. Yeah, I'm trying to find like I think there is a Rust library for it, but let me just make sure. Um, I think there must be like some bin packing algorithm implemented in Rust somewhere. Yeah, so Crunch implements a rectangular packer for cramming many rectangles into a larger container with sprite packing and texture. Okay, maybe this is what we want. There are a bunch of like game game design, or I guess game development libraries that do need to do stuff problems like this, actual like problems like this for game development. I think they need to solve stuff like this. So a rectangular packer written in Rust for cramming lots of rectangles into a larger one. But we don't so the thing is our points are not rectangles. Does this thing only accept rectangles? Can I tell it? Can I give it a polygon? Let's look at the previous one of the previous examples. One of the libraries we've used for the other. I can't solve it, so I was just checking if GPT can give it a correct solution. Actually worked. Okay, nice. No, that sounds good. I would prefer to use a library before asking GPT, but if I can't do it, I'm gonna also probably do the same thing. I just want to be done with this. All enumerations of all geometry types of code. So we can construct a polygon like we did last time, and is there is there a function we can use in polygon to pack spaces? So I don't think there is closest from concave hull with concave hull. What does that even mean? Contains. There are a bunch of contains for different types. Contains properly. Blah 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 blah. So there is a calculate coordinate position, chords count, return the number of coordinates in polygon. There is a covers. So that's what we used for, I think day 9 or something. Covers. There is a covers implementation, but there are fits or something like that. There is a distance within distance. I'm gonna, yeah, let me just try this. Are there Rust libraries out there that implement a space packing algorithm? I'll give them a list of polygons and a region to fit those polygons in, and the polygons can be rotated and translated to fit within the given region. I'm gonna say search. Hopefully that will search for it and find something good. But okay, so we have implemented the parsing. Let's look for more functions in here. Distance within, distance, distance, Euclidean distance, deprecated, deprecated. Okay, from, okay, it's like creating a polygon. Okay, geodesic perimeter area assigned. Now, hash intersects. We just try to rotate them until like, and if they have not intersected, maybe map coordinates. I don't think that will work. Relative equality assertion with relative limits. I don't think there is a function we can use in this thing. And what let me search for something like pack. Let's say something like fit. Yeah, there's nothing there. Let's clear this out. So there's crunch, there's pack. So you give it the container, that's a rectangle of this size, and the items are this rotation allowed, rotation allowed. Our this library is exactly what I want, but it only implements it for rectangles. But our shapes are not guaranteed to be rectangles. Our shapes are polygons, right? Yeah, it's like they are polygons, or I guess they are a cloud of points, or like you can think of them as polygons with zero width, or like no interior space, just the outline. Yeah, it's something like exactly like this, but if that works, that supports polygons. Let's look at this. Maybe divided polygons. Um, This is exactly what we want. An item. It's the width and the height. Yeah, annoying. Max rects. It's all for rectangles. An implementation of the max rects algorithm for solving 2D bin packing problems. Discrete implement shelf packing and guillotine packing and random respectively they are designed for them. And no, I guess for let's say polygons. Babushka. That babushka have what we need. It only has 10 stars, but it seems to be something we want. What did the GPT say? Okay, closest to what you described: irregular polygon nesting packing, Jaguar arrays backend for 2D irregular cutting and packing problems, collision detection plus problem modeling, supports strip packing, bin packing for it's intended to be used by an optimization algorithm. The author also provides a simple reference comparison to create LBF. Good if you want to implement plugin your own replacement rotation search, but don't if you Babushka, okay, 2D geometry focused on bin packing with a no-fit polygon inspired by SVG.NET. This one is more directly relevant plus more better. Core building by no-fit polygon. Okay, composes and no-fit polygon, which is a common primitive. If your region is rectangle, or you can approximate rectangle packers like RectPacker exists. I think maybe let's look at Babushka. I think maybe that's the closest thing we have now. So we can, I don't know, okay, it doesn't have much of a documentation. You can create a bounding box. I guess this will be the thing we're trying to fit stuff in. And then you can create a no-fit polygon. What is a no-fit polygon? Compute no-fit polygon. let's go into their source code. We did see that source code earlier. They have examples of polygon, slide distance, rotate segment, NFP piece polygon. Okay, these are not like these are not gonna be vertices, so maybe we need to modify that. But here, okay, they already have like a translation and stuff implemented here. But let me see if they actually have the what's Terashima? Draw your regular bin packing problem. Scale with height sound. Okay. And then what's the other example? It's robust polygon, including affine, rotate, translate, and backend ops, which are useful for. Let's look at the. I already know about this. That's annoying. This is annoying. This is very annoying. Maybe since we have the list of points, we don't actually need to construct a polygon. That's what I'm thinking. This might not even be correct. This could end up being an unmaintained library. Redux race babushka. I feel like this is an unmaintained library because they don't have anything. They just have demos. Okay, so we don't. Okay, our container is rectangular and the shapes we need to fit are no, we need to our container is a rectangular in a discrete grid, and we have a list of all points that represent the shape in that grid. Our container is rectangular in a discrete grid, and for like, yeah, I think that makes sense. I wonder if there's like a very simple, because it's not actually like a polygon, because even in our example, like it's just a list of points. Maybe just rotating them and stuff is easier. So for each one, let's see how many rotations are there. So it can be like this, it can be like that, it can be like this. So you can rotate it like that. Or there is also a translate, so you need to shift it down, shift it to the right, like flip it. I don't think that's gonna work, probably. It's probably gonna be too much possibilities. I'm also gonna say we can generate them and see if they work. Exact solver, shape representation, polyomino helpers, geometry, a polyomino fixes error related utilities only for manipulating. Okay, solvers that fit grid parking wherever exact. Implements Newt's dancing links DLX for exact cover constraint problems. This is a very common way to solve a problem in Tiny. Once you generate all the valid placements, including rotation translations, Escove, another Rust exact cover approach which you implement where you implement exact cover problem and user provided search dancing links. So okay, solver new 7. What is it solving though? We can add an option saying option 1 is, and then the solution. What? We can't use strings. What is this? A constraint problem, blah blah blah. Each of the options covers some of the items. Picking option 01 might involve selecting blah 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 blah. This can be expressed in. Okay, I don't get it. This is achieved by. So you just created a bunch of options. You created a solver. So you said we have 7 options, and our option 1 is this, option 2 is that option, and then just next solves it all. Or we can use strings in case we remind to generate the options. Is this a Sudoku solver? Define a Sudoku grid. 0 is the known number, A is unknown number. Sudoku new from input. That's not what we want exactly. What's our Xcove? What the heck is Xcove? that's not it. Scove rest. Let's search for this Nuts algorithm thing there. Nuts dancing links. In computer science, dancing links is a technique for adapting and deleting a node from a circular doubly linked list. Okay. Okay, I don't know if that's gonna help. The crate provides an implementation of Nuts blah 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 blah. The following pure exact. What? How can we use this to solve our problem? Uh, it's maybe this is giving it like a width and a height, so we can just fill the and then just fill them, try to fill them naively and then try to solve them. The LX builder, what does that accept? You in primary and secondary, the primary and secondary items with no options. Okay, show me an example. Let's see how we're gonna solve them. Now we maximize packed. What about geometry? What is it? Rest. Find a rectangle like this. Define a polyomino. Fix the number of points. Fix the number of points. Oh, it's gonna create a bit mask. Ugh, I hate bit masks. I hate it. It's just implementing it itself. What the fuck? I guess we can look into this. Two example pieces are occupied grid cells, so we have this list of these points as well, and then pieces, all placements, enumerate all placements. Enumerate all placements. Take the pieces, and then for each pieces, unique rotation, and then shape to mask. Ugh. Convert a set of points into a U1 to it mask on your container query. Unique constraints, no, unique rotations 90, return unique 90-degree rotations of a shape, normalize to mean. Okay, take, it's implementing. Use the example, the libraries, the crates you listed above. Okay, presents can be rotated and flipped as necessary to make them fit in the available space, but they have to always be placed perfectly on the grid. shapes cannot overlap. That is, the from two different presents can't go in the same place on the grid, but they can fit together. That is, the dot part does not block another present from occupying the space on the grid. Aves needs to know how many of the regions can fit the present state, blah blah blah, in this above example. So okay. What I think we found a good uh, so a polyomino is a good name that we should know about. Two example grid shapes, tetramoins from geometry. You can replace this with polyomino tetramonosky. Okay, if your type is okay. Okay, and then it created a bunch of cells, which is already what we have. Dynamic tile, enumerate all placements, and just enumerate all placements. It got the list of pieces and rotate cells, rotation 0 quarter turns. I guess maybe we can, let's try. Let's actually, since it, let's try opening up cursor, and let's try doing something like this. So open a main.arrays, and let's actually implement. So let's implement rotation for this. So let's say implement present and function rotate, and then this will be like a, I guess rotation will be, it's not gonna be, I think are like partial rotations. They haven't said anything about it, but they said presents can be rotated and flipped. But in our grid, I don't think there could be like a, like I don't know. It's the only rotations we're gonna accept is the 90-degree rotation, like maybe like turning, and then 180-degree. So like the four axes is like 270 and 360, which is gonna be the same, right? So like I think here it's listed the rotations somewhere around here. If I search for 270, yeah, so 0, 90, 180 and 270, I think those are the valid rotations we know about. So let's say enum rotation, and I guess right, and then rotate. Okay, so and then function flip and then I guess let's call this enum flip horizontal vertical and flip, and then so enumerate function enumerate I guess all rotations, or what do we call this? All transforms. Wait a minute, it's not gonna be on rotation, it's gonna be on present. Right, I think this is it. So I think that is this the all rotation. So um, is this actually all the transformations we should be checking for a grid? Mm, good point. Um, I don't know if this is actually all right. So I'm gonna I'm gonna do this. I'm gonna do this. Something like this. So I'd say another thing it should be doing is returning a hash state, and then let's go to let's implement hash, and then it's imported from here, and okay. So I'm gonna have it implement display for present function, and not like that, but let's say let's get grid equals, no, let's say let width and height, yep, that's what I want. And down here let's say let present equals input dot present at index 0, and then you say let transforms, and for transform in transform, yeah, let me see it, cargo run, uh, mm, 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 mm. Cannot move out of a debug, but I guess print. It's not correct. Let's debug. Let's remove that debug here, and let's go back here. So this is the first, and then we got this, which is totally incorrecto. Incorrecto. This is exactly what we started with, and then this one ended up being a number with a bunch of negatives. Bunch of negatives. Come on. I don't think the functions we just created are correct, the rotation functions. I think they are. I don't think they are correct. But why is that? So it's just inverting them in place. It's not taking into account of the width and height. So let's select width, height, and it's not even using those in there. The rotations don't seem to be correct. We want to rotate them within the width by height grid. I am seeing negative numbers. What? Who asked you to read the example.txt? Um, yeah, I think maybe this seems to be more correct because it's now contained within the width and height. But we can check that by running this. Okay. Don't think that's true. Okay, it is true. So this is another rotation. This is not correct. I don't think so, because they ended up being two positions in here. I don't think that's correct. No. Just gonna feed it this input then. Right, this is correct. This is like a flip, the first flip, and this is not correct. It was supposed to be rotated, but a new pound got added there. This is not also correct. Not correct. So I think those are all the possibilities, all right, that we should be checking for. There's still an error on these two conditions here. Skip it, but I don't think it's still correct. Okay, this is correct, that's correct, and this is wrong. And this is wrong. Screw this. I don't think this is gonna work. I think this is gonna work. Let me remove this, all of this stuff. Then let me run cargo format. How long have we been here? 1 hour and 20 minutes. Okay, let's say we are given a list of presents that can be rotated and translated, and we are expected to find the regions where all of the presents can be fit within the given region. Present counts represents the presents that should be placed at that region. The index in the vec determines which present we want to place, and the U32 value determines how many times that present should be placed in the grid. Hopefully I'll just copy over the entire Advent of Core input, but I don't know. I don't. It's like I'm not gonna implement a space packing algorithm here. I don't even know where to start. It's searching how our presents rotated. Okay. You're just gonna sit here waiting for cursor. Yeah, it's just annoying. Let's see who else has solved it. Let's go into leaderboards view. Oh, David Getachew has solved it. Maybe you can see his code. Not sure. Oh, the puzzle is, it's the last puzzle is, so okay, so these are the presents will be given. So you wanna like shape, because like this shape is represented by these pounds. So hidden structure yellow shapes. So this is the second shape, this is the third, the fourth, the fifth, the sixth shape. So on that end, like a shape of this size, and then we can rotate them or flip them however we want. And then the problem is we get given a list of regions here, and then it's a 4x4 region, they got a throated biomist region. So, and then these numbers represent how many times that the given the present at that index should be placed within that region. So for example እዚህ ጋር 0 1 2 3 4 ከዛ አራት ላይ ያለው value 2 ነው. We're gonna go into the fourth shape. So what it's saying is in this 4x4 grid the fourth shape should be placed 2 times. So እና if like እንደፈለግነው rotate ማድረግ ምናምን እንችላለን, ግን they cannot overlap each other. So the problem, the question is how many of these regions these regions can fit the presents that they were provided. So that's basically the question. It's like a space packing, a bin packing problem. We tried to find a bunch of like bin packing libraries in Rust, but none of them seem to work the way we want them to. And I just gave up, and I'm just having Cursor do it. Still in the yeah. It takes too much time. It takes too much time. It requires it's like a full-time work almost. We're just having Cursor do it, so we just explained the problem to it, and it's we had implemented the parsing. So earlier we implemented parsing those into like structs and stuff, but we're now having Cursor implement the actual generating all the possible transformations and applying them to the grid, checking if they overlap, stuff like that. So I think it's going well. It's generating all of the placements, all of the rotations, and all of the translations. It's returning them. It's not optimizing it. It got stuck. Maybe is there a timeout for this thing, or is this gonna wait? It's just gonna just sit there and wait. Let's see, keyboard. Yeah, okay. But I think it got stuck. Your solution is taking too much time. Yeah, this is the check I was talking about earlier, checking if the total area exceeds, because we can just count them up. Yeah, it's still taking way too long. I think generating all the positions is not the way to do it. Yeah, I don't think that's gonna. I don't think that's they have already filtered those. I don't think that's that. I think that's always false in our inputs. Um, adding check for presence with no valid placement optimizing. Okay, and optimizing. Literally no idea what's happening. Maybe I'll just, when we reach 2 hours, I'll just turn off the stream. Yeah. But I don't think I'm gonna be able to solve it. Space. Let's check out Chris Biscardi. No, let's Chris. Where is his GitHub? GitHub. Let's check out his GitHub. And Advent of Code. Oh, day 11. Okay. Yeah, he hasn't finished implementing day 12 yet. Maybe, I guess. If it's struggling this much with the example, I don't think we have hope for the actual input. I'm just sitting here waiting for Cursor to do its stuff. Oh, this is annoying. What do they expect us like to implement a space parking algorithm ourselves? It's like research only space parking algorithms. It's like I think people do like this is where people do research and stuff, not like we're looking for puzzles, not homework. I guess. And another term we learned about, I guess, earlier is try every rotation on every instance of the shape. Yeah, that's what we try to do. We try to generate all of the transformations earlier, but I think the transformations we are generating were wrong, and Cursor is already, I think, trying it, but one of the examples has like too many shapes, so the search space just becomes way too large, and it takes way too much time to compute all of those. I think there are known algorithms out there that do spatial optimizations, like but yeah, I think that's the way to do it. But basically, yeah, that's how you would do it, I think. What I was gonna say is what was it? Polymino. Let's say polymino space parking problem. Some like tiling libraries, tiling a space parking. It's a Rust. I feel like there should be so we create a new model and we fill it. I guess this is not what we want. Tiling is a library for constructing a tiling of regular polygons with their dual tilings. It's not what we want. Polygon parking. That's just way too much stuff. Is there like a brute force solution? Yeah, I think, yeah, there is a brute force solution, but I don't know if that's the way to do it. Let's run. I think it's finished. I think it finished. Wait a minute, it just said that didn't print anything, but it said that was a success. Cursor just gave up on it. Where did he get this log? Did he just hallucinate it? Okay, so in that case, then stop. Yeah, we have to cargo run dash dash release it. Okay, let's go here and see. In this example, two regions can fit. The answer is wrong, so undo all, and the answer should be 2. Let's say it's reading the files itself, but I maybe give cursor the other input instead of tell it to. So I think it's already in there, so it's reading it. It's in this example file, so yeah, I think we can, if we gave it all of this, I think it will have enough context to do it. Yeah, let's maybe up to somewhere around here. Yeah, this is all of the intro, but below the example input is the actual like requirement, so maybe we can give it that. If Chris Biscardi like pushes his solution, we could use his, but oh, I know what's going wrong. It should be returning it should be returning the count. Calculate sum of region indices. No, not sum, but count. That's what's going wrong. Will it realize that? I think it is correct. It's just I think let me stop it. Keep all and instead of sum, this should be count, and stop. It should be count. If we actually get our paddle input now and see how long it takes, let's say save, move inputs to the current directory, and here let's call it input. $591. Let's see if that's correct. Okay. Wait, I thought it didn't have part 2. The elves thank you profusely for the help. Start rearranging the oddly shaped presents. As you look up, you notice that large more elves have arrived here at the Christmas tree farm. In fact, many of these new arrivals look familiar. The elves you help while decorating the North Pole base, right on schedule. Each group seems to have brought a star to put atop the Christmas trees. Before any of them can find a ladder, a particular large Christmas tree suddenly flashes brightly when a large star magically appears above it. As your eyes readjust, you think you notice a portly man with a white beard disappearing into the crowd. You go look for a ladder. Only 23 stars to go. You don't have enough stars to finish decorating the North Pole. You need one more. Although it hasn't changed, you can still get your puzzle input. Oh, what? It's. Oh no! I think it's because you go look for a ladder. Only 20 stars to go. You don't have enough. You need one more. Although it hasn't changed, you can still get your present input. Why would you give me the paddle input again? I think so. The problem is, I think the problem is so day 12 cannot complete the final check for day 12 requires us that we've completed day 10 part 2, but we didn't implement the day 10 part 2. We just skipped it because it was just too difficult. Whoa, okay. In that case I'm just gonna do this. Let me just do this. Commit with day 12 part 1 with cursor. Wait a minute, it's saying we didn't complete it because let's go into Christmas card solutions. We have time, so let's go into which one? The day 10. We skipped the day 10, so let's go into day 10 source part 2. How did it do it? We are already parsing them, right? So process. Yeah, it's like, did you see what it said? Did you see what it said? Right at the end, it said you can't finish 12 because it said you have like you can't finish the actual thing. Maybe it's not showing me part 2 because I haven't completed day 10 part 2. I'm gonna maybe try using so. Let's finish that now. Let's do it. Let's go up. Let's go into day 10. and let's copy PR part 2, and let's go into part 2. Let's cargo.toml part 2, and let's see what we had in here. I forgot how we did it. So there was a mean process function, set hint false for each machine. Okay, how did Crispy Scardy do it? So he also iterated over each, but what did he do? Okay, per iter he added rayon. Let me just copy that there. Gonna paste that here and remove, maybe go to Daytane. I'm not gonna do I don't think I'll ever maybe like after 2 years I'll do it, but I'm definitely not gonna do Advent of Code next year. Definitely not. Cargo add rayon. What else? We don't need that. We don't need this. Let's remove that there. And okay, so per iter comes from rayon parallel iterator. Our machines is also a wake of machines. It's not an iterator, blah 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 blah. What does his machines return from machines function? Now it also returns a wake of machines, so that should be correct. Let's see, cargo, no, it's cargo R, and remove that. Okay. Into parallel iterator. Rayon slice machine is not an iterator because maybe it should debug. Is that what we need? Is that why it's complaining? Why is that not an iterator? Mutable slice. These items can't. Machine also implements debug. Maybe it's because it doesn't know about push button, but let's get push button. Right there. Oh, okay. We imported the wrong thing. Let's go back here. Oh, god damn it. Okay, let's just get the prelude. Give me all of it. Prelude. Start. Drag. Okay. And each machine has a state. What is it? State is a Vaco view size. Oh, I guess in our case we called it lights, so it's just lights then. Okay, lights as a state. Let's say, how are we? Okay. No, that's not it. So we don't care about the lights. We just have a state, which is vec, something like this. Junctions. Let's rename that to that, and this is gonna be, I guess, a vec of view size, like we wanted. Let's remove that. We don't need that. I think don't need that anymore. and then here instead of we can say state, and this is a vec 0 duplicated by junctions dot lane. Yeah, that's what it did. Then this is state, and then so okay, so it has the buttons, but how is he representing the buttons? How are we representing the buttons? Button is a button, which is a button. Where is button? Oh, button. It's gonna be a lights. So let's forget about this, and this return a vec of users2 or vec usize, and then say usize, and then okay. What else? Guess this should also be a usize then. Usize. Yeah, they didn't allow us to see it. I think they didn't allow us to see. On line 73. There is a difference in how we are parsing the buttons. I think it's using a button. Where is that defined? How did ID not get used? Okay, it's just for logging. It's just for telemetry stuff, but here it said trade unnamed. Okay, blah blah blah. Panic dot lane is 2 but index is 2. Not run with lane is 2 but index is 2. Maybe there is something they add in here to the buttons or the state. It's the same thing. We did the same thing here. Did the same thing here. We did the same thing with the jolts. Get up. What's the diff between these two? I think there is a difference. Process returns the let's see. Okay, that's the total, so that's what we're doing. We return the total. If I is equals to, if I modulo 1000 equals 0, they log it. Now they just continue. Set contains jolt. Don't know what's happening. Do we remove something when we are porting it? No. I think all of it is correct. Where is this goal function being used? I guess that's what parses the. That's what used to parse the lights which are no longer being used. Let's close it and open it in here. Is there a difference in implementation between and this? I don't see anything that's actually different. Let's make this example. Okay, so found a critical bug in state 964. The with 2 elements creates. Oh, that's good catch. Good catch. Oh, nice. That's a good catch. So in Rust there are like 2 syntaxes for like the wake macro. Wake macro. So if you just do a comma here like I did earlier, this will just be a list of 0, comma, and then the length of the thing. But if you say semicolon, it's 0 repeated by the second number I give you, which is the length. And that's why we were getting a bunch of index out of bound errors, because it was always ending up as a vector with 2 elements inside of it. So I think that's correct for the example, but if we run it for our input and cargo run dash release, it will take some time, but hopefully we'll get the right answer, and hopefully they will unlock day 12 part 2 for us. I didn't know they did this, by the way. It's like you have to complete all of them to get the last, to even view the last question, the last did they do this to me on other, like on previous years? Let's go to the previous year. Let's go to 2021, for example. Can I just go? I guess I didn't do part 1. I think I did in 2023, so I did day 25. Where is day 25? So day 25. No, they gave me the first star, but okay, yeah, so they complained, oh, power requires now 49 stars, you need to get 11 more. Yeah, come on, I didn't know they did this. It's annoying. Oof, how much time is this thing gonna take? I don't think this will be it. Yeah, I think he didn't even finish implementing part 2. I think he just gave up. I think the guy we're reporting it didn't even finish part 2. So let's find for Rust Datain part 2. Let's look for solutions for Datain part 2. How long have we been streaming? Let's say almost 3 hours. No, 2 hours and 7 minutes. Okay. Are there any Rust part 2? What did they say? Finally got this done. For part 1 is basically brute force, some pruning. For part 2 I ended up building a linear equation system using rational numbers and doing Gaussian elimination. And if there were any what? Python in 0.5 seconds for both? What kind of magic is this? Oh, they used Z3. This is like a theorem solver. So for Datain part 2, like it ended up like you would need to use like some kind of theorem solver to actually solve it. Let me just do this. I don't think this is gonna finish. So what dependencies do they have? Let's create let's see. Let's go up and let's create a Python directory. I'm gonna stop this. It might even make my system crash. The PC is already getting too hot. Let's create a Python directory. Let's go into the Python directory. Let's do uv init. It's downloading Python. Okay. We're gonna use this Python solution, and I think they only import Z3. So we'll copy this. Now I guess we'll copy the whole thing, and we need to implement etartools. No, we need to install etartools and Z3. I think it will solve it. I think. Yeah, okay, let me just go back here. Okay, so it finished initializing. Let's go into main.py, delete all of that, add this, and then try to uv run main.py. Of course there is no input file. Main.py. According to you, the input is gonna be at /part2/input/input.txt. No, not band.run. Okay, so we need to uv add z3. uv run main.py. Solver is not defined. We did just install z3, right? Which version of z3? Come on. Maybe we need to add uv add etartools. I think it's part of the standard library. No solutions found for the dependencies. I think etartools is part of the standard library in Python, right? etartools. Yeah, I think it's part of the standard library. Yeah, but this doesn't uv run main.py, and it can't find solver because from z3 import everything. Let's say import solver specifically. Let's do that. uv run main.py. Import name. Cannot import name solver from z3. I'm gonna comment out part 1, delete it. Just gonna UV run from, I guess maybe it needs to be at the top of the file, I don't know, from these 3, import everything. Oh, I have to do UV activate or something, or I thought UV did that by default. UV sync. Am I using UV the correct way? Export format Python VM, create a virtual environment, build into source, blah blah, build cache. I think I'm UV and then run a command or a script. If I did UV run, it will run it with the current project. Why is UV run not working? Am I PWD? Yeah, I'm in the correct direction there. Directory. I don't know why UV is not working. Maybe this example just different, using a different version of the Z3 library. Oh, okay, we need to okay, I don't know. Oh, we installed the wrong thing. We installed we installed this. We should be installing Z3 dash solver. We just installed the dash Z3. Okay, hopefully this is correct. Okay, now let's go to day 12 and you have enough stars to finish decorating the North Pole. Okay, you helped the elves decorate the Christmas trees with all 24 stars. Now the elf will be happy of time, blah blah blah. My website, Blue Sky. I've highlighted the Easter eggs in each puzzle just in case you missed any. Okay, let's share this on Blue Sky. Basically, no. Cursor did it, not me. Also install a Python solution for the 18 part 2. Okay, in that case I guess we're done with this bullshit. We're done with this bullshit. Let's go into here. Let's see the animations for a little bit. They look nice. Okay, what else am I gonna need to do? I'm gonna need to close cursor. I'm not gonna do any kind of cleanup. I'm just gonna commit everything I have, and I'm just gonna call this commit fit get it done. Thank you. I don't know, I guess I'm just gonna get it done. I'm just gonna get it done. Whimsical font class push, and let's go into the readme. Let's go into day 12. I guess the language didn't change, so 12. Sure, update readme push, and what I'm gonna need to do one more thing. Just gonna copy this. Just take a screenshot. I didn't know this went through across the page, across the full page. Yeah. Okay, I'm gonna take that screenshot and I'm gonna post it here. And I guess there's also another thing I wanted to do. So this thing, die-on1 dash. I wanna list all of the language we used in one place. So this is we should go to this, close that. Advent of code. We used Elm. What's the next one with the? I guess Rust has 4 letters, so the next one is Rust. And what has 5 letters? Idris also has 5 letters. What about Unison? 1, 2, Unison had more. Idris and O'Connell and so the 6 letters. 1, 2. Gleam also has 5 letters. So Gleam. And then is there another 5-letter one left? I think there is. Then we used Unison and TypeScript. I think these are all the languages we used. So 1, 2, 3, 4, 5, 6, 7. We used 7 languages. Yeah, so we used 8 different languages still. Did I miss? Oh, I missed Haskell. Haskell has 1, 2, 3, 4, 5, 6, 7. So it should be between Unison and Haskell. So we used 8 different languages first. I guess 7 different languages, and we started repeating. Rust. So in total there should be 8 different languages. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think we used 8 different languages. We could have used Go and Zig or something, but I don't know. I got into a functional groove, so we implemented the first 7 days in functional languages, and we just kept going. And for the final days, because the problems just got too hard, we just decided to use Rust. Yeah, but I guess as always the best language to do Advent of Code with is definitely Python. Yeah, so I'm gonna post this. Just done with Advent of Code. These are the languages. Okay, so that has been posted. I think it's being posted. Am I offline? Okay, so goodbye everyone. I guess see you. I'm not gonna do Advent of Code next year, but I don't know. Maybe the year after that, 2027. Yeah. Bye bye.